Hello folks, this is Robert Bontrager. I want to create just a series of videos here that kind of show you how to do some simple sending and receiving of laser tag signals with using the Arduino microprocessor. And this is something that I've taught myself, learned how to do because I had some ideas on some different types of gadgets that I wanted to make. And once I figured out how to send and receive laser tag signals, it just opens up with all sorts of crazy things that you can do. So I want to show you some basic ways of how to do these essential things, to send a laser tag signal and then to receive a laser tag signal. So this first video, I'm going to show you how to send a laser tag signal using the Arduino. Okay, so I'm going to use a couple of things here. First of all, what you're seeing here, this is the IDE for the Arduino program. But we're also going to get some information online on what makes up a laser tag signal. So if we go to here, this is a website, Google Patents. If you do a Google search for device and method for an electronic game, you'll pull up the original patent for the original 2004 LTTO Deluxe, which is great. This is all online. And so when we pull up this PDF, this is what you get here. This is the original patent. And we can see our friend Brian Farley. He's one of the inventors here. But we're going to go through here and we're going to get some information on what makes up a laser tag signal, because we have to know this in order to replicate it in the Arduino. And once you understand this, then you can replicate it. So basically a laser tag signal operates with pulses of infrared light, and the infrared light turns on and off at 38,000 kilohertz, 38,000 times a second. And so when it's pulsing at 38,000 kilohertz, there's a receiver on the laser tag gun that sort of inverts that. So when there is no pulse, the laser tag receiver will send a high signal. But once it sees a pulse, that signal goes low. And then once it's inactive, then the signal goes high. This is what's received on the laser tag gun. So that's important to know as we come down here. So that this is a basic signature format. So you have a pulse here, then you have a dead space, and then you have a sync pulse, and then you have your data. So on the sync pulse, for a beacon signal, it could be 6 milliseconds, or a received, if it's a tag or data, it's going to be 3 milliseconds. So that's important to know. Okay, that's the sync pulse here. 6 seconds for a beacon, milliseconds, and 3 milliseconds for the sync pulse. Okay, and then for the data up here, if it's 1 millisecond, it's going to interpret it as a 0. If it's 2 milliseconds, it's going to interpret it as a 1. Okay, and so if we scroll down some more, this unpacks what a beacon looks like. If you want to replicate a beacon signal, this is kind of how you do it, but we're going to replicate a tag signature. Okay, so we have a 3 millisecond pulse followed by a 6 millisecond dead space. Then we have a 3 millisecond sync pulse, and then we have our data. And our data is in 1, 2, 3, 4, 5, 6, 7 different types of bits. These are bits. 8 bits makes a byte. So this isn't quite a byte yet, but we got 7 bits of information. A bit can either be 1 or 0. And so we got TH, TL, PH, PM, PL, X2, and X1. This is the information that each laser tag signal on the LTTO gear sends. So what does this mean? What is this information? Well, I think if you were to scroll down here more, you could learn what that is. But another good resource is this Laser Swarm wiki page. And people who run this have went to great lengths to reverse engineer the information coming from the laser tag. So we're going to come here to protocols, And we're going to come here to the infrared protocol. And we want to learn more about the tag signature. Okay, so tag information, 7 bits, which is what we saw here, 7 bits. So we got 1, 2, 3, 4, 5 things here, and then we got 2, x2, and x1 here. So the first part is the team and player number, and then the other 2 is the tag strength. So our x2, x1 is how much strength our tag is going to be. So 0, 0 is going to be 1 tag, 1, 1 is going to be 4 tags. Cool. So we could send anywhere from 1 to 4 points worth of damage in our tag. Question is, what do we do about this? What is these all need to be 0, 1s? What is all this? Well, it just depends on what it is you're going to send the tag information for. What are you going to represent? So let's click on this here. And so the first 2 is designated. If it's 0, 1, it's going to represent someone on team 1, team 2, and team 3. So that's what these first 2 digits represent. What team? Team high, team low. Okay, now if there's 0, 0, it's going to be special players. See below. All right, special players, 0, 0. So the first 2 digits, 0, 0, which means, oh, we're going to do a grab and go. So if we have these 2 0, 0, and we do the rest 0, 0, 0, so the first 5 digits are all going to be 0, that means we're going to replicate a tag for a typical solo game, and that's what we're going to do. If we change this bit to 1, which is this one, to 1, then it would be a grab and go for team 1, and commercially team 2 and team 3. Okay, and there's some other information down here that we could replicate as well. But we're not going to do that. We're just going to replicate just a solo grab and go game just for this demonstration. Cool. So this is what we need to replicate in Arduino to make a tag. Great. Now we understand this. So let's go to the Arduino sketch and do this. Okay, so if you've never programmed an Arduino before, it's very simple, very easy. I encourage you to go look at some tutorials on how to do this. But I'm just going to walk you through exactly what I do. So when you program in Arduino, this is a blank sketch. You download the Arduino. It's called the IDE. And you download this to your computer, and then you can start programming stuff. And this is a blank sketch. Sketch is what they call the programs. And it's using a program, or the program language is called C. And everything in this brackets here is in this function called setup. So this is the setup function. This is the loop function. Okay, and we can create other functions too. Okay, so here's what we're going to do. First of all, we're going to go on up and we're going to create a variable. And I'm going to just type this in here. Constant byte, and we're going to call our variable IR LED pin equals 5. Okay, so what we have to do anytime we declare a variable is just basically we're using a name in place of a number. Okay, and we are telling Arduino that how much memory space do we want to allocate for this variable, which is a byte, and a byte is 8 bits, and so this value can be anywhere from 0 to 255. Okay, other variable types is an int, and so forth, but we're calling this as a byte. Constant means we're telling Arduino that do not change. This value is not going to change. This variable will stay at 5. Nothing can change it. So it's a way to kind of protect it. It's sort of like a safety. And so this is our IR emitter pin. Next, we're going to do another variable. And these variables are going to be our LTTO tags. Okay, so this is the tag, or we'll call it tag information. Okay, if we come back to our pattern here, we got the different data here, TH, TL, PH, PL. I'm just going to copy these names. Okay, we typed all the information here that matches what the patent says. And so everything's a value of 1. And this 1 refers to 1 millisecond. and that will give us a value of the bit as being 0. If it's a 2 millisecond, then it'll give us a value of 1. So right now these are all effectively will be read as a 0 in the laser tag receiver. Perfect, great. Now we're done defining our variables, so we're going to go into the setup. So we're going to come over here, hit tab, and we're going to do pin mode IR LED pin output. And so what this is going to do is it's going to tell the Arduino that IR LED pin, which is 5, is going to be an output. Perfect. That's all we got to do in our setup. So now we get to our loop. We want to send a tag. So I'm just going to go that, send tag. And what I'm doing here, I'm basically making a new function. I'm going to say, okay, loop, go to the function send tag. Okay, I haven't created that function yet, but I'm going to create the function here in just a moment. So I'm going to say, go to the function send tag, semicolon. Great. After you've done that, then we're going to wait. And we're going to have a delay of 5,000 milliseconds. Now, a millisecond is 1,000th of a second. So 5,000 is going to be 5 seconds. So we're going to wait here 5 seconds. And after that, we're going to resend the tag again. So let's go ahead and create that. So we're going to say void send tag. So the first thing that we want to do when we look at our sketch here is we first send a 3-second pulse, wait as milliseconds, 3 millisecond pulse, wait 6 milliseconds, then go 3, wait 2, and we just follow this pattern. So this is what we're going to do. Perfect. So what we want, the first thing is to pulse IR for 3 milliseconds. You're going to send 3, the value of 3, into this function. I haven't typed out the function yet, but this is what we want it to do. Okay, so we want to send a pulse 3 seconds. After that, we want to delay 6 milliseconds. Then we want to pulse another 3. And just keep repeating this. I'm sorry. So we do 3, 6, 3, and then after that we do 2. Okay. And so now what we want to do is we want to pulse the value of TH, because that was our first one here. Okay. The reason why we're using variables because later on, maybe in our sketch, we want to change the value of TH to a 2. Okay, we could do that. All right. But right now it's a value of 1. We're just going to send that, which is send a pulse of 1 millisecond. Whoop, pulse IR. Going to make sure I name our sketches the same. Great. So now I'm just going to finish typing this out for everything. Okay, so I've typed everything out here. And we're done with sending our tag. Okay, so now what we have to do is flesh out this pulse IR. So how are we going to do this? Let's type that out. Now this is what literally, I had one method on how to pulse the IR, and I used it for many years, and it worked okay, but I had some problems with it. And it wasn't only until recently, maybe about a year ago, I came across with this newer method that works so much better, and I get more consistent results, and it's so easy to understand. Our function is void pulse IR. And so now, since we're sending a value here, we need to receive that somehow into a variable. So we're going to call byte milliseconds. So how many milliseconds? So this is what this is. Our variable is called milliseconds, okay? and a bracket here. So everything in this bracket is going to be in our function pulse IR. This is so simple. So the magic sauce is this word, tone. IR LED pin, which is pin 5, 38,000. Yes, what you do is you send a tone to your IR LED pin, and you're telling it to send a 38 kilohertz tone. And this works. So now we delay milliseconds, and then we go no tone. We have to turn it off. And that's it. That is it. That's all you have to do to send a laser tag signal. That is it. You don't have to download a complicated library and install it. And I mean, there's libraries out there, and I look at them, I just have no clue what they're doing. But this is all you have to do to send an infrared signal. Okay, so now I'm going to hook that up to an Arduino, and we're going to see it in action. Okay, so now we're going to assemble this. This is a standard breadboard we're going to plug some components into. We have an Uno here. I've got an infrared LED, and one lead is longer than the other. As you can see, one lead is longer than the other. So this is the positive, this is the negative. And so our signal from pin 5 is going to go into the positive end. I don't know if you can see pin 5 there. And then our negative end is going to go to ground. So we're going to wire this up like this. We're going to use, on the breadboard here, a lot of the tracks that go lengthwise. So this, I don't know if you can see where it says A, B, C, D, and E. So all those are all connected here. So if I put something in here where it says A, that means everything on this first row is going to be connected. Just A, B, C, D, and E is connected. But since we're going to hook up a ground to this LED here, we're going to put the ground into our negative channel here. And then our positive is going to be up in there like that. So hopefully you can see that all right. Okay, so what we want to do now is we want to connect the other end of this to pin 5. And so we'll look on here where pin 5 is, and it's clearly marked. Pin 5, like so. Okay. Great. So now we just got to hook up this to a negative voltage. Now, when using LEDs, it's important to use a transistor or a resistor, because you want to limit the current going through here. So if you have like a 10 ohm resistor, it would be recommended you put that in there. But we're just going to throw caution in the wind and just going to go straight through. And the pulse is so short. So some of you are more into electronics than I am, might not appreciate that and would really want to see a resistor in there. But I'm just going to go ahead and do it like this. Okay, so that's it. That's all we got to do. So our LED is wired. Great. So now let's go ahead and we're going to plug this in. We have this connect to a computer here. I can't really see that. But all right, so here's my sketch. And let's just verify that this is going to work. And sure enough, it works. Okay, so we're going to go ahead and upload this. And you always want to make sure that you are on the right port. COM3 and that you are using the right board. I have an Uno here, and so you want to make sure you're using what you have there. There's so many different Arduino boards out there, but Uno is the most basic one. That's what I have here. Great. So let's upload this. Okay, and we're done. We've now have this sketch on this board here. Let's see if this works. So I've got a LTX here, and we're going to go to solo. And we're going to see if we get tags. Now, I don't know if these can get tags while they're counting down or what, but let's see what happens here.
Good luck.
There we go, every 5 seconds. We're getting hit. Nice. Let's try a different one. Let's try the deluxe, the classic, one of the best laser taggers ever made, the deluxe.
Good luck.
So there I think it was getting hit while it was doing the countdown. I believe that's what was going on. So every 5 seconds we're getting hit there. There we go, 5 seconds.
Warning.
Nice. Turn that off. Cool. Let's try the 2012 model.
Good luck.
Yay. Perfect. Every 5 seconds getting hit. Let's make some changes. I'm going to change these two to a 2 to give us 4 points worth of damage for every hit. Shall we try it? Let's do it. We're going to upload our code. And I'm going to go back to the deluxe because we can actually have a readout of what's happening here. So I'm going to start this under the table. Let's see if we avoid getting those hits while it's doing the countdown, because it's 4 hits. Okay, so we're not getting hit there. All right, so here we go. Four points worth of damage. Look at that.
Warning. You're out.
Just like that. Sweet. So now you have the power to create an incredible weapon. So with great power comes great responsibility, or something like that. So don't break the game for other people, but use your knowledge for good and have fun. Next video, how to receive a tag. How to receive a tag. It's great to send a tag, but if you could create a device that can receive a laser tag signal, or maybe even a beacon signal, what could you make with that? So we're going to look into that next time. Thank you. Bye-bye.